Hello guys, this is going to be an AP review question for a category of problems that I would call a graph problem. We have I'd say like 7 or 8 different categories where the question is centered on that topic and they keep coming up year after year. And one of them is they're going to give you a graph. A lot of times it's a graph of a derivative, and that's what's happening in this case. And they're going to ask you all sorts of questions. So what we're going to look for is from year to year patterns of things that they ask, and these are kind of interesting questions because a lot of times they are asking us about the most basic level Calc 1 topics, but they ask them in a complicated way, and it's tough to look at a graph of a derivative and sometimes make conclusions about the function or the second derivative based on looking at the derivative, because it's hard to take what you see and not apply it to that, right? I'm not looking at the graph, I'm looking at the function's derivative. So let's just see what they ask us here. We have a graph from 0 to 8, horizontal tangents at 1, 3, and 5, which is what it looks like. They're just confirming that that's the truth. And it gives us the area, so we're not going to have to integrate anything to find these areas. They're just giving them to us. So let's start with A. Find values of x between 0 and 8 for a local minimum. Okay, so let's think about what that means. For f to have a local minimum, that means f itself has made a dip. So what's true about f is f goes from decreasing to increasing. What's true about f prime is f prime went from negative positive. So what we're looking for in part A is where does the graph of f prime go from negative to positive? And that happens right here at 1, 2, 3, 4, 5, 6. So x equals 6 is a local or relative min. And what's our justification? We can justify that because the graph of f prime changed from negative to positive. All possible values, by the way, that we should have considered were whenever the function's derivative was equal to 0, because one of the basic ideas from Calc 1 is mins and maxes occur when a derivative is 0. So this was an option, this was an option, and then our answer was an option. But the only one where the graph went from negative to positive was at 6. So there's question A. All right, let's move on. What's it asking us in B? Absolute minimum. Another big idea from Calc 1 is an absolute minimum happens at either a relative minimum or an endpoint. We're looking for the absolute smallest value of f on this interval. So one of our options is at the relative minimum that we just found, which is x equals 6. And then other than that, we have our endpoints, 0 and 8. An absolute min might not happen at a relative if it's at an endpoint. Like if this is my window and my graph does something like this, I might have a relative min here, but my absolute min was down there as soon as the interval started. So what we need to do is check our relative min and our endpoints. All right, so one of our endpoints is given to us. F of 8 equals 4. So that's one possibility, and that's starting on the far right-hand side. Now, here's a theme that happens on a lot of these questions. Where you end up is where you were plus how much you've changed. So if I end up at a height of 4 at x equals 8, I can see how much I've changed by kind of working my way backwards. And these areas, remember, your change in your function value is pretty much the integral of the derivative. The integral of the derivative, generally speaking, gets us back to just f level, and if you integrate it from starting point to stopping point, that's how much you've changed. So let's start at 0, basically. If we were to start at 0, everything above the axis is accumulating positive area. So on our way from 0 to 8, we have a plus 2, a plus 6, a minus 3, and a plus 7. And that's a difference, let's see, 30, 40, 15, that's plus 12. So in moving from 0 to 8, we accumulate 12 units of area. Now, if we end up at a height of 4 at 8, let's put this in equation form. Our value at 0 plus 12 got us up to 4, to simplify things. Whatever my height was at 0, when I moved all the way over to 8, I gained 12 units. That's the sum of those green numbers. Therefore, f of 0 had to be negative 8. All right, so that's now in the running for absolute min because it's a height of negative 8. Okay, and then similarly at 6, you can kind of start on in either direction. Now, if I was at negative 8 at 0, by the time I get over to 6, 1, 2, 3, 4, 5, 6, in moving from 0 to 6, I gain, what's that, 8, I gain 5. So where I was at 0, which is negative 8, plus 5 is where I am at 6. So f of 6 must equal negative 3. So if you consider your local min and your two endpoints, the lowest value out of all of those is negative 8. All right, absolute min on the closed interval 0 to 8 is at negative 8, and that happens at x equals 0. All right, moving on, part C. What C is going to ask us is this. I'm going to move these down so I can keep the question showing. All right, part C. On what open intervals from 0 to 8 is f, not the picture, but f, which is the, this is the derivative of this function f. Where is f concave down and increasing? Okay, so let's deal with the increasing part first. If a function is going to be increasing, its derivative needs to be positive. All right, so this is a picture of the derivative. So when this thing is positive, f is increasing. So that much, these are possibilities for increasing, right? F prime positive means f is increasing. Now, what's our other hold on, this yellow is bothering me over here. Come back. Okay, better. Next condition, f needs to be concave down. So concave down means the second derivative is negative, okay? The second derivative is the derivative of the first, or the slope of the first derivative. So we need to find places where this graph is decreasing. It has a negative slope, because a negative slope here means a negative second derivative. So in blue, I'm going to highlight all the places where this thing's decreasing. It's decreasing there, and it's decreasing here, and then it increases the rest of the way. All right, so the overlap, the green is my answer, because the yellow means my graph is increasing. F is increasing. The blue means it's concave down. So my answer is F is concave down and increasing. From 0 to 1 and from 3 to 4. And you don't do or equal to in these. You aren't concave down or increasing at the endpoints themselves, just in between. Because f prime is positive and decreasing. This type of thing happens over and over again every year. Interpreting what it means to look at this picture and make conclusions about the graph. All right, so they're not always obvious, but it's based on some basic facts that you should have known for a couple years now. All right, so part D. G is defined by f cubed. Fair enough. Whatever function I have, I cube it, I get G. F of 3 is negative 5 halves. Find the slope of the line tangent to the graph of G at 3. Now, I read that one the first time and think, uh-oh, this is one of those confusing ones. I don't know what to do. So whenever I feel like that, I'm just going to start by just deciphering what it is they're asking me for. They're asking me for the slope of the line tangent to the graph of G at x equals 3. Well, slope of the tangent line, that's just the derivative. They're asking me for the derivative of G at 3. Okay? Well, if I have a function for G prime of x, then I can just plug 3 into it. So let's see what G prime of x is. G of x is f of x cubed. Therefore, G prime of x, I'm going to take the derivative of something cubed. Whenever you take the derivative of something cubed, it's 3 times that same thing squared, and the chain rule says we need an extra f prime. So here's a function for G prime. And if you want to know G prime of 3, just plug 3 in. G prime of 3 is 3 times f of 3, and they told us in the question f of 3 was negative 5 halves. So if you answered this without using that negative 5 halves, then something's wrong. And now we need f prime of 3. Well, luckily we have a picture of f prime. At 3, f prime is equal to 4. So multiply all that together, and you get 75. So that one wasn't really difficult mathematically. You just had to know what was being asked, and that's what happens over and over again on these AP problems. All right, so there we go. That's our first AP review of a graph problem. So bring your notes to this on class, and I'll see you then. Young out.